Hello everyone, my name is Atharv Chauhan. So today I'll walk you through two very popular machine learning techniques, k-means clustering and k-nearest neighbors classification. One is unsupervised, the other is supervised, but both rely heavily on distance calculations. My goal is to explain everything in clear and human-friendly way, so you understand not how they work, but why we use them. So let's dig deep into it. We are very close to end our series. It's our question number 7 of and sim solution series. So consist part A of and part B. Part A of k means clustering, part B of k nearest neighbors. So let's see what we'll cover today. So let's see the presentation overview. Here's what we'll covering today. Basics of clustering and where it's used. Step by step working of k-means algorithm. How centered initialization impacts results. A practical example with distance calculations. Understanding KNN classification. And let's begin with clustering now. Now, what is clustering? Clustering is an unsupervised learning technique, which means we don't have labels. Instead, the algorithm looks at the data and tries to group similar points together. Some real world applications include customer segmentation in marketing, organizing articles and documents automatically, image compression by grouping similar colors, anomaly detection like spotting fraud. In short, clustering helps us discover hidden patterns inside unlabeled data. Now, k-means algorithm step by step. K-means is one of the simplest and most popular clustering algorithms. Here's how it works. Choose k, the number of clusters, initialize centroids randomly or through k-means plus plus. Assign points, each point goes to the nearest centroid, then update centroids, take the mean of point in each cluster, repeat until the centroids stop moving. Now the iterative process continues until the clusters stabilize. Now, what is Euclidean distance? The core idea is both k-means and KNN rely on the same concept, Euclidean distance, the straight line distance between 2 points. In k-means, distance decides which centroid each point belongs to. In KNN, distance helps identify the closest neighbors for classification. So, understanding distance is key to understanding both algorithms. Now, let's see why initial centroids matter. The starting centroid in k-means can drastically change the final clusters. Bad initialization means more iterations and poor clusters. Good initializations means fast convergence and strong results. K-means plus plus improves this by smartly spreading out initial centroids, giving better and more stable clusters. Now looking at the practical dataset example, let's walk through a simple example to really understand about the k-means. Our data points are 2 comma 10, 2 comma 5, 8 comma 4, 5 comma 8, 7 comma 5 and 6 comma 4. We select k equals to 2, so we want two clusters. Initial centroids chosen are 2 comma 10 and 5 comma 8. Now we look at the first iteration step. Now we calculate the distance from each point to both centroids and assign each point to the nearest one. After doing this, 2 comma 10 and 2 comma 5 go to cluster 1 and all the other points go to cluster 2. Now we have two clear groups. Updating the centroids, we compute new means. Cluster 1 equals to, just a second, cluster 1 equals to 2 comma 7.5, cluster 2 is 0.6.5 comma 5.25. Then we recheck distances using the new centroids. Since no points change clusters, k-means has converged. Interestingly, we reached convergence in just one iteration because the initial centroids were well placed. Now, what is KNN classification? Now let's switch to a supervised technique, KNN. KNN stands for K nearest neighbors. It works on a very simple idea. Data points that are close to each other likely belong to the same class. KNN is used when you already have labeled data and want to classify new points. Now, how KNN works? Here's the process. Calculate the distance from new point to all training points. Select K nearest neighbor. Majority voting, whichever class appears the most wins. And assign the class to the new point. It's simple, it's intuitive, and surprisingly powerful, especially for small data sets. Now, talking about the final summary now. K-means is an unsupervised algorithm that forms clusters based on similarity. Centroid initialization can impact cluster quality and convergence. Equilibrium distance is the backbone of both algorithms. KNN is the supervised algorithm that classifies new points using the nearest neighbors. Both methods are essential tools for pattern recognition and prediction. So, yeah, that is for question number 7, covering both the parts. Thank you for listening. Thanks for watching this